Hello everyone, this is Orhan Erdem. Welcome to today's video where I will delve into common challenges in data analysis, missing values and scaling issues. The data we analyzed up to now was stock prices data. Stock prices data generally do not have missing values, or they don't have any columns with categorical values. It might be the case that you might have data with missing values or columns with categorical values. We are going to analyze right now Boston house prices data in which some of the values in some columns are missing. Now what are we going to do in that case? Let's dive in. Okay, this data set is called 2023 Roxbury, and these are the house price valuations assessment in the Roxbury region of Boston. So first let's import the data set and then let's take a look at the first 5 rows of the data. Okay, as you can see, there are a lot of columns here, each of which is a different characteristic of the houses. So each line represents a house and each column represents the characteristic of that house. For example, land SF is square feet of that house. This is gross area, and this column, which says total value here, represents the assessment of the value of that house, and then comes gross tax, year built, etc. So this line shows you where the data set is from. It's from data.boston.gov. Now let's take a look at the columns, how many columns we have. So these are the names of the columns. We have 16 columns, some of which are categorical values. For example, LU is a categorical value. Heat type is a categorical value, and prop view is a categorical value. Okay, first of all, let's see the descriptive statistics of this data set. House DF is the name of my data set. And then I'm going to ask Python to show me the descriptive statistics. As you can see, when you use this describe command, Python does not even take a look at the columns with categorical values. But if you look at the count row of this descriptive statistics table, you can see which values has how many numbers of data set. For example, land square feet has almost 6,102 data, but gross area has 4,000, and a number of bedrooms, for example, this data set has 3,588, which means that it has a lot of missing values. So what are we going to do if we have missing values? Well, there are a couple of ways. First way is to drop them all. Okay, first let's drop them all. Okay, so I'm going to create another data set which I will call reduced DF, and it's going to be house DF data set with dropped missing values. Let's take a look. Reduced DF describe. All of the columns says 3,582 data. The remaining rows, almost 3,000 rows, they're all dropped. Instead of dropping all those missing values, you might fill them with median, for example, or mean of the remaining values. So this is what I'm going to do. I'm going to first create a variable which is median bedrooms, for example. So number of bedrooms was the data set with the most missing values. So the house DF, this is the name of the variable, bedrooms. So put them in these quotation marks and then calculate the median. So this is going to be the median value of number of bedrooms. If you want to see it. So the median value is 4. So what I'm going to do is I'm going to fill all the missing values with 4. If a house does not have data about their bedrooms, it's going to be 4. So this command is just filling the missing values. Now, if you take a look at the descriptive statistics of the house DF data frame, you would see now the bedroom data column, which is bed RMS, does not have 3,500 data. It is now 6,168 data because we filled them in. Now it is 6,168. So there are a couple of commands that I used here. First of all, fill NA is filling the missing values. And the len shows length of the columns with non-missing values. Now I'm going to review a different methodology which is called normalizing or normalization. Normalization is needed in some cases when the columns of the data have different scales. For example, one column might be in millions and the other columns might be in tens, the other columns might be in thousands. So in that case, most of the methodologies does not provide you a way to compare the effect of different columns, so you might need to normalize the data set. Normalization is basically subtracting the mean from the data and dividing it by the standard deviation. So let's review our data set once again. Descriptive statistics. What we are going to do is we are going to now drop the categorical values because I'm going to subtract the mean and divide by standard deviation. So for all the columns, since categorical values does not have mean or standard deviation, you can't do it for those columns. So first of all, I'm going to drop all the missing values that I did not fill. So I'm going to create another data set. Let's call it house df version 2. So this is going to be house df with missing values dropped. Now I'm going to also drop all the columns with categorical values just because these data are not quantified. Okay, now I'm going to define normalized data. Okay, lastly, I will show you the descriptive statistics of this data set. So just to remind you, normalized house DF is going to be the house DF data set with missing values dropped and normalized. So I'm going to compare it in a moment. So these are the descriptive statistics of my new data set. As you can see, this is my original data set. This is my new data set. In new data set, each column had 3,582 values, items, meaning that all of the missing values are dropped. And these are the mean, standard deviation, minimum, and maximum of the data set. As you can see, the standard deviation of all columns are almost exactly the same. It's 1 because we normalized them, which literally changed the data, but in a scale. So all of the data set, they are all brought to the same scale. Well, for the categorical values, as you might have realized, we did not do much here just because we are dealing with quantitative variations of the data set. In the coming videos, I'm going to show you how to create quantitative data columns from categorical value columns. Right now, I just dropped them to deal with the rest. Well, it is famously said, you can have all the fancy tools, but if your data quality is not good, you are nowhere. Data often does not arrive in a clean, well-organized form. Much of the data we retrieve from the websites contains missing values or issues with scaling. In this video, I showed you how to deal with missing values and how to normalize data. I hope you enjoyed this video and hope to see you in the next videos. Bye.